Hello everyone and welcome to today's webinar. Thank you so much for joining me. Today I'm going to talk about automatic configuration of your safety logic with the DeltaV SIS Configurator. So this means that you can use your Silver tool, your Design SRS tool, to automatically configure your safety logic with a plugin we've created for exSILentia. So that's pretty cool, but before I get started, I'm going to introduce myself. My name is Kate Hildenbrandt. I'm responsible for strategy, roadmap, and feature definition for exSILentia software. I am also here for customer training and support. So any questions you have, you can email me directly at khildenbrandt@exida.com. Little background on exida. There are three main groups in our company. We do lifecycle services, we do enterprise tools, and we do certification and assessment of devices as well as personnel. So we believe that all three of these things can help bring a deep knowledge and understanding to your project to help you achieve safety while optimizing your process for your whole company or for one project. We do have locations internationally. I myself am located in Sellersville, which is right outside Philadelphia, Pennsylvania, but hopefully you'll see some office of exidas that is close to you. So I'm going to start by talking about the functional safety lifecycle as defined by IEC 61511. And I'm sure most of you are very familiar with this life cycle, but in case you're not, it provides a guideline to help you analyze inherent risk in your system, design a solution to mitigate that risk, and verify that solution by tracking performance, by keeping up with your plant performance during operation to basically validate that your design is working. I do want to focus on the design and implementation phase of the life cycle today, and that includes three pretty important tasks that I'm going to zero in on. The first is SIL verification, and this is where you do your design calculations for your safety instrumented system. Usually, you start in the analysis phase with PHA, LOPA, SIL selection, and that helps you to define your design criteria. Then you're going to document that in a safety requirement specification meant as a handoff to the design team. That's when your SIL verification starts. And here you're going to model your safety instrumented functions and determine if they achieve the target risk reduction or target safety integrity level. Once your conceptual design is complete, you have to document that. And so that's where the design SRS comes in. And this is meant as a handoff between the design and the implementation phase of the life cycle. And so this is documenting the requirements for installing your safety system, starting it up, and ongoing maintenance. The next step would be the configuration of your safety logic. So somebody has to interpret this information and configure the safety logic for your safety PLC. The standard has a lot to say as far as requirements go for your application programmer or logic solver configuration. So here you can see on the right-hand side, there is a lot of verbiage in the standard about these requirements, your SIS application program development. And I'm not going to go through all of it, but you can see it's rather extensive. These requirements are divided into general requirements, application program design and implementation, requirements for review and testing, and then the application program methodology and tools. So it's pretty extensive in the standard. I have attempted to summarize it here, but basically the crux of it is that your configuration of the safety logic has to be consistent with your design. There has to be traceability and documentation throughout. So all your design requirements have to be included. Each SIF and its SIL level has to be identified. The inputs and outputs have to be identified and traceable. You're going to need version control and history of changes. And the program must be modular with limited complexity. It's got to be easy to test and have one-to-one mapping with the hardware. So that's a lot to take on. And most of the time, I mean, we've given this presentation a few times, and we find that people often say that when they configure their safety logic, they actually start doing this in the analysis phase. And the reason is because they have some idea of what their safety system is going to be. But you know as well as I that when you get into the design phase, certain things can change. You might have to implement more or less redundancy, so that would affect your inputs and outputs. You might have to change your testing strategies. You might have to change your implementation strategy, so trip delays, things like that. And so it's often better to have this traceability to complete your conceptual design before starting your application program. And what I'm going to talk about today would help with that. So the crux of it is the conceptual design and application program logic, the information that you're using to complete these tasks really overlaps. So when you're doing your SIL verification, your SIL calculations, you're already defining the relationship between the inputs and outputs. You're inputting into the tool process ranges and set points, your trip direction, and any trip delays or maintenance overrides. So I mentioned a tool. If in fact you're doing this in an electronic format, then that information's already there for you. This can be leveraged to automatically generate the application program logic. Often what we do these days is you have your SIL calculation and you have some outputs. Most of the time this is going to be in the form of a cause and effects matrix, and somebody will print out that report and they'll take it and they'll interpret it to manually configure the safety logic. And this is a perfectly fine way to do things, but to be able to leverage the inputs into your SIL verification calculation in your design SRS, you're not only going to save time, but it's going to drive consistency. So let's take a deep dive into this concept, and then I have a test case I can talk about where we use the DeltaV SIS Configurator on a project. So as I said, you're going to start with your SIL verification. Here I have a screenshot of our Silver tool in exSILentia. And this is where your conceptual design is done. You're going to model the SIF, so you're going to determine your SIF architecture. You're going to specify equipment for your sensors, logic solvers, and final elements. You're going to define the mission time and demand modes, as well as the proof test strategy and your ongoing maintenance strategy. Specifically for the devices, there's a certain amount of information that you're already putting into Silver and the design SRS that also pertains to your safety logic configuration. So for the sensors, you're already defining the number of input channels, the voting, if your trip is high or low, if you have any out of range detection needs, if you have trip delays, what is your action upon transmitter fault detection. You're defining your tags, your tag ranges, your trip point, and your engineering units. So some of these things you might already be putting into Silver. Some of these things you might not have known existed in Silver, but we do have a place to put in tags, all of this. And then some of it is innate to simply modeling your SIF. For the final elements, there's a little less information, but it's just as important. You have your number of output channels, again, your tags, and your action that your final element is supposed to take. And we found while doing this, the structure of Silver and the structure of the application program is pretty similar. So let's take one SIF for an example. This is a high pressure loop. It's a pretty simple SIF. We have 3 initiating tags, so you have 3 pressure transmitters voted 2 out of 3. The trip point is 25 bar. You have 2 valves closing, and they are voted 1 out of 2. And then you have a manual emergency shutdown button as an input as well. Now here I'm showing you the same SIF, but I'm also showing you the safety logic as it's configured for this SIF. And obviously you can see some similarity in the structure. So let's dive a little deeper into this. Your sensors specified in the SIL verification become inputs for the application program. So here it looks in the SIF like you have 2 inputs, but in reality we know there are 3 pressure transmitters voted 2 out of 3 going into the logic solver as an input to the logic solver. And then you have that emergency shutdown button as well. as an input to the logic solver. The pressure transmitters are voted 2 out of 3, and so that sensor architecture and voting information is going to be configured in your voter block. Next, you have your logic solver information, which is configured in that CEM block. And finally, your final element specified and modeled there. You have, it looks again like you have 1 in the SIF, but in reality, we know that you have 2 final elements voted 1 out of 2. So those are your outputs in the application program. So that's pretty straightforward. You see how the structure of this already works and that much of the information you need is already in Silver. But it doesn't stop there. We still have our design safety requirement specification. So in this document, you're documenting all the requirements for implementation. And this includes things like maintenance overrides, bypass management, startup overrides, your trip delay, and reset options. And I want to highlight here, you can also input your auxiliary inputs and outputs. And so this is a little funny because when you're doing your safety function calculations, you usually don't include your auxiliary inputs and outputs. In fact, you shouldn't, because it would impact the calculation in a negative way. However, for application program configuration, you want to take these into account, and so you are able to put them in the design SRS there. So you're taking account of those inputs and outputs as well. And finally, when all of this is done, when you've completed your SIL verification and you've completed your design SRS, you can generate a file from exSILentia that can be used to create a configuration file for your application program. In this case, we're talking specifically about DeltaV. Now, you can do this after you complete your entire safety instrumented system, or you can do it one SIF or unit or area at a time. And so this depends on how you want to do it yourself, but it's capable of either. You might want to do it as you go while you're doing your design, or simply all at once. But that file can then automatically configure the safety logic in the application program. So here you're looking at Control Studio and DeltaV, and you can see it's not exactly the same SIF, but a SIF configured in there. So this is done basically in a matter of seconds. Depending on the output, you might need some massaging depending on your application, but it's a very fast, easy solution. It's going to drive consistency. So it sounds pretty great, right? But let's talk about an actual project that we did this with. We had an end user that was replacing their safety PLC, and they requested help validating their SIL verification. Their calculation file was then used to configure logic for their new PLC. And so this was a perfect test case to try the DeltaV SIS configurator out. The calculation file consisted of 26 SIFs with SIL requirements from 0 to 2. The system was also to be implemented with 24 inputs and 9 outputs. So here is your cause and effects matrix. Again, the scope included 26 trip signals. We had a mix of analog in and digital inputs. We had 2 high-low voters. So it's pretty straightforward, but some interesting things in the scope. It's important to note that the SIL verification calculations and the design SRS were completed prior to planning to use the tool to generate code. This poses some problems, not much. We're going to talk about how that affected the project. But the configuration file was generated with a few errors related to tag name nomenclature. So if you're a user of Silver, you know you can put your tags in, but it's mostly for reference, right? Maybe it's exported into SILstat for recording your failure data, but it's not really going anywhere else unless you're using the configurator. In this case, if you're using the configurator, those tags are used in your safety logic, and so they have to follow the nomenclature needed in that system. So in this case, the tag names were revised to match the application program's format. So with all those errors fixed, the configuration file was completed and it was open in the application program. Again, once the configuration file is generated, opening it up in the program takes a matter of seconds. Some massaging was needed, some minor modifications, including replacing the digital outputs with secure parameters, adding in references for those parameters, and adjustment of engineering units. So much like the tags, in Silver, you can put in engineering units any way you want to. You can type out degree C, you can just put C, you can do GC, but in the application program, there has to be a specific format, and so those needed adjusting. And with the secure parameters, that's actually something that is possible in the program, but again, this SIL verification was done without knowing that the program would be used, and so that needed some minor massaging afterwards. So what are the results? First of all, it was successful. The safety logic was generated from the SIL verification and design SRS file. And so they were able to use this while replacing their safety PLC. It actually cut down the time to configure the safety logic by 50%. So that's a significant cut. And then, of course, the safety logic was consistent with the conceptual design, with a few minor modifications needed, as we said. So what are the lessons learned? Overall, the test case was a success. But as I said, some of the work was done before knowing that the safety logic was going to be generated from the conceptual design. In this case, I would say that that 50%, while impressive, could have been cut down even more if you had the application programmer with the design team as they were doing the SIL verification. Another important thing is basically to read the user guide. Those secure parameters that had to be massaged in later are possible to do with the tool. You can do that without having to massage it later. And so for a relatively small project, 50% is great, but we believe that further reductions can be expected for larger projects and once that learning curve has been completed. And so it was a great test case. It definitely highlights how a new user would use the tool and how much that can help them reduce their engineering hours as well. However, that even can be optimized further once you read the manual and maybe have both of the teams work together. So what can we conclude from all this? There are some obvious benefits to using the DeltaV SIS Configurator. This method is going to guarantee consistency between design and implementation, as we said. Again, I can't emphasize enough that when you have all the people in the room that would be involved in both the SIL verification and the application programming, you're going to save even more time by getting it done right the first time. And the idea is that you're entering the information into one tool once, and then that information is being used to do multiple tasks. You're leveraging that data that you put into exSILentia. So again, this takes a fraction of the time, and it's eliminating rework, which is obviously going to dramatically impact your project schedule. So let's take a look quick. I did put together a Gantt chart, and this does not pertain to the test case, but it does pertain to what we expect in a different test case you could do with a larger project and optimizing the time saved. And so, as I said earlier, many people start configuration of their safety logic in the analysis phase. And so you can see in the top Gantt chart, item 3, we have safety logic configuration first pass. And that's because a lot of people, assuming they have a tight project schedule and they need to get started on it, they think they know what their safety instrumented system is going to look like, and so they get started with that. But in reality, your conceptual design isn't finalized yet. And so once the conceptual design is finalized, we have a second pass in there. And part of that second pass is not only completing the logic, but maybe going back to rework some of the old work done before the design was complete. And then your final review might take a little bit longer to, close loose ends and make sure that everything's consistent and traceable. Whereas with the configurator, you see the second Gantt chart on the bottom, you don't have to configure your safety logic until your design is done. There might be a little massaging needed, and you definitely still need a final review. However, it shouldn't take as long because you've input the information into one tool that's doing your configuration for you. It should be traceable, and the information should certainly match. And so here you can see the true impact on the project schedule that we would expect over time when you get used to using the tool. And overall, this is going to guarantee compliance with your 615.11 requirements. So there are definitely some benefits to using this DeltaV SIS Configurator. If you have any questions on it that I haven't answered for you, please let me know. Again, you can email me at khildenbrandt@exida.com. But there you can see in this test case and in the benefits how we think it would impact your project. If you want to know more, you can find us on Twitter, you can find us on Facebook and LinkedIn, and you can email us at academy@exida.com with your suggestions for future webinars. We really like for you to let us know what you want to hear so that these are of value to you. Additionally, we have some courses coming up. We do have our first SIL Verification with Silver course coming up in Sellersville in a couple weeks, where we are training on version 4 of our Silver tool, which is really exciting. We have a few FSE 100s coming up, a few alarm management courses, so take a look. This is not by any means an exhaustive list, so go to exida.com/training and you can see the full public course list there. And that is it for today. Thank you so much for joining me. Again, please do not hesitate to send me any questions. And yeah, take care. Thank you.